In this lesson we're going to look at the general rules of integration and how they operate. Now integration is the exact opposite of differentiation. So if you take a derived function here, x squared, and you integrate it, what happens? Well, you should be able to see from here that the power increases by 1 and then you divide by the new power. So you increase the power by 1 to get 3 here and then divide by 3 so you get a third x cubed. So this bit's the integral of this function here. Next, if you integrate x cubed, you add 1 to the power and divide by the new power to get a quarter x to the power 4. Same idea here, except we've got a coefficient greater than 1. So add 1 to the 5 to get 6, and then you divide the 2 by the new power, so you'd get 2 over 6, which simplifies to 1/3. And lastly, 21x to the power 6. If you add 1 to the power of 6, you get 7, and then divide 21 by the new power to get 3. This is what this looks like in a more mathematical way. This is the integral sign. You have to use this every time you integrate. So we integrate a as a coefficient x to the power n, and you integrate with respect to x, the variable. Now if it's not an x that you're using, you would use dt or dm or any letter of the alphabet here. So we add 1 to the new power, and then we divide by that new power here. The additional thing here that we've got a plus c. Now c is a constant, it's called the constant of integration. Now the constant represents any constant term that you've had in the original expression, because if you differentiate a constant you get 0. So if you integrate that backwards, then you don't know what it was that you zeroed. It could have been a 6 or an 8 or a 9 or whatever. So we call that c the constant of integration. So always use this integral sign and dx on the other side with respect to x, or whatever the variable letter is, dt or so on. So let's look at the last thing before we start actually integrating some examples. You must be good at this idea here, dividing a whole number by a fraction. Because as you can imagine, the powers quite often end up as fractions. Then you have to divide a number in front of the variable. So how do we do this? 1 divided by 3/4. Well, 1 divided by 3/4 is exactly the same as 1 times 4/3. You flip the second fraction over. That's just from the rules of fractions, so that becomes 4/3. Same idea here, we think of it sideways as 3 divided by 2/5, and you can flip that over and become 3 times 5/2. Now when you're doing this, 3 times 5 is 15/2. You can think of it as 3/1 times 5/2, so you get 15/2. Okay, first 3 examples. So, integrate expressing answers with positive powers. Integrate x cubed with respect to x. So, add 1 to the power, divide by the new power, and then remember your constant, your plus c. Add 1 to the power here, and that will be -5, and then divide by -5. So it's going to be -1/5 x to the -5 plus c. Leave the answer with a positive power, so take the x down below and make it a positive 5. So -1/5x to the power 5 plus c. You need to remember this idea, x to the -5 is the same as 1/x to the 5. And lastly, integrate x to the power 3/4 with respect to x. Add 1 to the power here. So the easiest thing is to add 4/4, because we're adding 3/4 to 1. So add on 4/4 and you get 7/4, and then you do 1 divided by 7/4, which is 4/7, flipping it just like we did in the last screen, and then plus your c. So we have to remember here that 1 divided by 7/4 is equal to 4/7.